algebra and geometry? Yuck! But Miss Pocket Ronnie can help you.
Alright, we're going to be doing parabolas today. So, the simplest form of a parabola that faces up and down, the equation looks like y equals x squared. That is the simplest equation of a parabola. To remind you, a line, neither x nor y has a squared term on it. For circles and ellipses, both x and y are squared. So for a parabola, one will be squared and one is not. So this is the simplest form for an up and down parabola. So just to tell you what that looks like, this is going to start at the origin and it's going to be symmetrical about your y-axis and it's going to be facing up. The coefficient in front of here is 1, but we don't have to write that. If the coefficient in front of your x squared term is positive, then you're smiling. Okay? If your coefficient in front of your x squared term is negative, then you are frowning. So this is the simplest form of a parabola that faces up and down. Okay, going down here, parabolas can also face to the right and to the left. So when your parabola is facing to the right and to the left, now your y is squared and x is not. And again, if the coefficient in front of here is positive, it's going to face toward the positive side of the graph. So it will face to the right. So if your coefficient in front of here is negative, that'd be a -1, then it's going to face toward the negative side of the graph. So those are your simplest forms of a parabola. Alright, we can look at the general equation of a parabola. If we look at the parabolas that are facing up and down, your general equation of a parabola is this. One is squared, one is not. In this lesson, remember A, B, and C represent coefficients. In this lesson, your B coefficient is going to be 0, so there's not going to be a middle term for these parabolas in this lesson. You're going to have an x squared term and then you can have a whole number. So in your up and down parabolas, this coefficient will tell you, is it facing up or is it facing down? If it's positive, you're facing up. If it's negative, you're down. Positive, smiling. Negative, frowning. Okay? So this your coefficient in front of your x squared term also tells you how wide or how narrow is your parabola. Okay, we will talk about this coefficient in the next lesson, since right now there's not going to be any x terms in these parabolas. And then your whole number at the end will tell you, will shift your parabola up or down. If there is no whole number at the end, then your parabola will start at the origin. So if your whole number at the end is positive, it's going to shift up. If your whole number at the end is negative, your parabola will shift down. Okay, if we look at the parabolas that are to the right, going to the right and to the left, the general form of your parabola, your x is not squared and your y is. So you have ay squared plus by plus c. And again, there's not going to be any middle terms for this lesson. You're going to have a y squared term and a whole number. And again, this coefficient will tell you, is it facing to the right or facing to the left? If it's positive, it's to the right. If it's negative, it's to the left. This coefficient will also tell you how wide or narrow your parabola is. And this whole number will shift your parabola to the right or to the left. If it's a positive number, you're going to shift to the right. If it's a negative number, your whole parabola will shift to the left. Alright, let's take all this information and apply it to 24a3. You have y equals 1/3 x squared. When your x is squared and y is not, that's a parabola that's facing up and down. So the next few problems I'm going to do will be up and down parabolas. So the first thing that I do is look at this coefficient. It's positive. So this coefficient in front of my x squared term is positive, which means that my parabola is smiling. The problem asks you to estimate your parabola and then to plot some points to try to graph it a little more exactly. But as an estimate, I know that my parabola is facing up, and since there's no whole number at the end, adding or subtracting at the end, then my parabola will also face the start at the origin. Okay, so I know it's going to start at the origin. So this coefficient is positive. That tells me it's smiling, facing up. Then this coefficient also tells you how wide or how narrow your parabola is. The fact that 1/3 is a small number leads you to believe that it will be narrow, but it's just the opposite. The smaller your number, the wider the parabola. The larger the number, the narrower the parabola. So when you have a small number here, it's going to be a wide parabola. So I'm starting at the origin, and it's going to be something wide, and it's going to be smiling. So just as an estimate, I'm just drawing that. And then we will graph it on graph paper here in just a minute. The problem also asks you to plot numbers so you can get more exact. This is just an estimate of what it looks like, but we can get more exact numbers to plot some points. It's a good idea to plot about 3 to 5 points for these. I always start with 0. It's a good idea to pick a value for whatever letter is on the right hand side of your equation. Since x is on the right hand side, I'm going to pick values for x and then calculate my y value. So I always pick the origin to start with. So if I pick 0 for x, so if I put in 0 for x, 0 squared is 0 and 0 times anything is 0. Okay, so now let's just put in 1 for x. If you need to go work it off to the side, fine. So putting in 1 for x, that'd be 1 squared. 1 squared is 1, and 1 times 1/3 is 1/3. So if I put in 1 for x, then my y value is 1/3. Okay, I want to show you putting in a -1. Okay, I'm going to use -1 for x. Y equals 1/3, -1. It's important to write this as -1 parentheses squared, because now this ends up as a positive number. So in parabolas, you can always see that when you put in your negative value, the same value is going to end up being positive. -1 squared is a positive 1, and positive 1 times 1/3 is still 1/3. Okay, now I'm going to put in 3. So y equals 1/3, 3 squared. So that is 1/3, 3 squared is 9, times 9. That's like over 1. These cancel, and that leaves you with 3. So when x is 3, then y is also 3. What do you expect to get if I put in x equals -3? Now I just have a negative right there. -3 squared is still a positive 9. And then 9 times 1/3 is 9/3, 9 over 3, and 9 over 3 is 3. So I still get the same answer. So you can see when you put in your negative value, you're going to get the same thing as your positive value. So you don't have to do the calculations again. Okay? So now that I have these points, I will plot them on the graph. Alright, we're graphing 24a3. So remember, these were our points that we calculated. So graphing this point, 0, 0, that's at the origin. And then 1, 1/3, so over 1, up just a third. And then -1, 1/3, over -1 in the x direction, up just a third. 3, 3, over the x direction 3, 1, 2, 3. 1, 2, 3, up 3, 1, 2, 3. And then -3, 3, so 1, 2, 3, 1, 2, 3. And then this is our parabola. It will keep going. It'll get wider and wider as we continue on. And this is a little bit more accurate than our estimate, but it's still a rough draft. Okay, let's look at 24E, problems 1 and 2. You have this equation here, 2x squared equals negative y. It's important, just like when you graph a line, to put it in the proper form. For a line, you put it in slope-intercept form. The same is true for parabolas. You want to put it in the general form in order to graph it. The general form is, if it's an up and down parabola, y on one side, everything else on the other side. It doesn't matter if y is on the right or the left, but we have a negative in front of the y. That's like a -1. You can't leave a negative in front of the y, so we need to get rid of it. So we divide everything by -1, so that goes away. So we have y, and then +2 divided by -1 is a -2x squared. So this is our equation. Again, it doesn't matter if y is on the right or the left. Y equals -2x squared. When x is squared and y is not, it's an up and down parabola. This coefficient determines, is it facing up or down? It's negative, so we are frowning. So I'm not adding any whole number out to the side. So when I'm not adding any whole number, it starts at the origin. Because if I put in 0 for x, 0 squared is 0, and 0 times anything is 0, which makes y 0. So I'm starting at the origin and I'm facing down, I'm frowning, and then this coefficient tells you if it's wide or narrow. Remember, the larger the number, the narrower the parabola. So just as an estimate, I'm going to make my parabola look like this. Okay, but we can plot some x and y values to go back and fix it to make it a little bit more accurate. So again, it's better if you pick values for your squared term, whatever letter is your squared term, pick values for that, then calculate the letter that's over here all by itself. So I'm going to pick values for x. So I already said when x is 0, putting in 0 for x makes y 0. Okay? I just start picking simple numbers. I usually pick 1 and -1, and then I scoot out from there and pick something like 3 or 4 or something like that. So if I put in 1, so you have -2 and then 1 squared. So 1 squared is 1, and 1 times -2 is -2. So when I put in 1 for x, I got -2 for y. So what if I put in -1? -1 squared is still a +1, and +1 times a -2 is still a -2. So when I put in -1 for x, I got a -2 for y. Remember, if you put in the negative value of this, you should get the same answer because our parabolas are symmetrical. Okay, so let's just say I pick 4. And again, it's arbitrary. You can pick whatever numbers you want. But I would say you need to plot at least 3 points, and I would probably recommend 5. So because you need, this point right here is called your vertex. The very end of the parabola, whether it's the high point or the low point, is called the vertex. You need a point for your vertex, and then you need at least 2 to 4 points to determine what the parabola is doing. And parabolas will continue to widen out. Like this will continue to get wider and wider and wider as it goes on. So I said we're going to pick 4. So -2 times 4 squared. So 4 squared is 16, and 16 times a -2 is -32. So that's going to be way off my graph, so maybe I should pick a smaller number. So let's just pick 2 when x equals 2. So 2 squared is 4, and 4 times -2 is -8. So when x equals 2, y equals -8. So if I said x equals -2, -2 squared is still a +4, and +4 times a -2 is still -8. So now I can go and plot those 5 points. Okay, now we're graphing 24E number 1 and 2. Remember, these are the points we calculated. So starting at the origin, 0, 0. Now let's do 1, -2. X is 1, down 2. Now -1, -2, -1, -2. 2, -8, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So you can see how our parabola will be narrow. And then -2, -8. So this just shows you It will be narrow, and it does face down. Okay, we're looking at 24B1. I'm only going to estimate this graph. I'm not going to actually graph it on graph paper for you, but I will draw you a picture here and give you a few points to plot. So we have y equals 2x squared plus 5. Okay, so when x is squared and y is not, it's a parabola facing up or down. So that's the first thing you need to, remember. So then you look at this coefficient here. If this coefficient is positive, it's smiling. If it's negative, you're frowning. Well, we're positive, so we're smiling. So if I had no number here and I just had y equals 2x squared, and remember, the larger the number is, the narrower the parabola. If I didn't have any number out to the side, then I would be starting at the origin, and it would be something like this, okay? I would be smiling, and it would be a narrow parabola because this is getting to be, it's not a large number, but it's not a fraction. But now that I have this plus 5 out here, the whole numbers that are added out to the end tell us that our parabola is going to be shifting up or down. If this is a positive number, then we are shifting up. If it's a negative number, we're shifting down. So if this number wasn't here, this is what our parabola would be like. But now that we have this here, our parabola will shift up 5 spaces. So on my graph, if I had 1, 2, 3, 4, 5, my parabola will look like that, but I will just take it, it will look the same, and I will just shift it up 5. 1, 2, 3, 4, 5. So the vertex of my parabola is there, and so really this is the actual parabola that we are looking for. It's that parabola but shifted up 5. And again, we can plot values just to prove that. Again, pick values for whatever your squared term is. So I'm going to pick values for x and calculate y. So again, I always start with 0 if x was 0. Well, 0 squared is 0, and 0 times anything is 0, and 0 plus 5 is 5. So that confirms what I just graphed up here, that my vertex point is 0, 5. 0 in the x direction, don't go anywhere, and then go up 5, and that's my vertex. Okay, so let's just pick 1. So putting in 1 for x, that would be 1 squared is 1, 1 times 2 is 2, and 2 plus 5 is 7. So if I put in negative 1, I should get the same value, because negative 1 squared is a positive 1, times 2 is 2, plus 5 is 7. So that at least gives you 3 points to start with in graphing this. So going over a positive 1, then up 7, and then a negative 1, then up 7, is at least 3 points to start with graphing this graph. Alright, we're looking at 24D, 3 and 4. We have the equation of y equals negative 1/2 squared minus 1. What we always want to look at is it in standard form? Is it in the general form of a parabola? Y is on one side and everything else is on the other side? Yes. So x is squared, y is not. When x is squared and y is not, it's an up and down parabola. So then we look at this coefficient. This coefficient is negative, which means we are frowning. So we know right off the bat, just as an estimate, it's going to be facing down. And then this is a fraction, a smaller number. Smaller numbers means a wider parabola. So if that number wasn't there, then we would be starting at the origin, and it would be facing down, and it would be some sort of wide parabola. But now that this number is here, these whole numbers at the end tell us if our parabola will be shifting up or down. Since this is a negative number, we will shift down. So you just take this whole parabola and shift it down 1. So since this is negative 1, then we just shift down 1. So my vertex is now there, and I still have the same parabola, the same thing, I just shifted down 1. So this would be the estimate for our answer. So again, we can graph points, we can plot points, calculate some points to graph. So again, pick values that your letter is the squared term. So always going to start with 0. So if x is 0, 0 times negative 1/2, or 0 squared is 0, and 0 times negative 1/2 is 0, and 0 minus 1 is negative 1, which that confirms our estimate, and just doing a rough sketch, that our vertex is at 0, negative 1. Okay, so now I'm just going to pick numbers that are multiples of 2, so it will cancel with my denominator. Okay, so I'm going to pick 2 because that will cancel with my denominator. So if I put in 2, so I have y equals negative 1/2, 2 squared minus 1. 2 squared is 4. That would be like over 1. So that would be negative 1/2 times 4 over 1, because 2 squared is 4. My 2 and my 4 cancel. Don't lose your negative sign. So that would leave a negative 2 right there, minus 1. So y equals negative 3. So when x is 2, y is negative 3. If I put in negative 2 right there, I'm going to end up with the same answer, because negative 2 squared would be a positive 4. So if I do a negative 2, I'm still going to end up with a negative 3. That should be enough points. I'm just going to do 3 points. Well, I'll go ahead and do another one. 4. Let's put in 4. Although that could be off my graph on my paper. So y equals negative 1/2. 4 squared minus 1. 4 squared is 16. So you got negative 1/2 times 16 minus 1. That's over 1. 2 into 16 is 8. So that's a negative 8 minus 1. That's a negative 9. So when x equals 4, y equals negative 9. And then if I put in a negative here, it will be the same value. A negative 4, negative 9. We said our parabola was facing down, which means I should be having negative numbers for my y values. So when you calculate your points, make sure your points match with your estimate. So, okay, so now we have our points. We can go graph those. Okay, 24D, number 3 and 4, graphing it. Here are the points that we calculated, so graphing those. Don't go anywhere in the x direction, but go down 1. So our vertex is at 0, negative 1. Now 2, negative 3. 1, 2, 1, 2, 3. Negative 2, negative 3. Remember, these are supposed to be symmetrical, so your points should be symmetrical. 4, negative 9. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4. Negative 9. This is a little bit more accurate than what our estimate was. Okay, we're looking at 24B4. 3x squared equals y plus 1. My x is squared, my y is not, which tells me it's an up and down graph, but I need to put it in standard form. Okay, it's not in the general form of a parabola, to where y needs to be on one side and everything else on the other side. So I need to subtract 1 over, so that goes away. I can't add whole numbers to x squared, so I can just write this as 3x squared minus 1 equals y. Okay, now it's in the proper form. So now I can look at this coefficient. This coefficient is positive, so therefore I know it's going to be smiling. It's facing up. It's also a larger number, so therefore I know it's going to be narrow, a narrow parabola. So as an estimate, we can come over here. If that negative 1 was not there, it would be starting at the origin, and it would be facing up. Okay, so it would be a narrow parabola starting at the origin, doing that, but since that negative 1 is there, that means that whole parabola shifts down 1. That negative means down. So you take the whole thing and then just shift it down 1. So instead of starting at the origin, it's going to start right there. That will be the vertex, and then let's erase that first estimate, because then this will be a narrow parabola because this is a larger number. So this is the estimate of what it should look like. I'm not going to graph this one for you on graph paper, but I will get you started on a few points, just plotting a few points. So if I pick values for x, putting in 0, 0 squared is 0, 0 times 3 is 0, and 0 minus 1 is negative 1. So our y value would be negative 1. So that confirms our vertex at 0, negative 1. So now let's put in 1. if I put in 1 for x, 1 squared is 1, 1 times 3, because you have that 3 out there. 1 times 3 is 3, and 3 minus 1 is 2. So if I put in negative 1, I should get the same thing. Negative 1, 2. And then these are just a few points to get you started on graphing it on your own.